All right, we are moving right through Unit 1. We're now on Section 1.4. Here's the I can statement for 1.4. I can solve and graph inequalities. So let's write inequalities. And the first thing is the warm-up, and it says this: what is the difference between an equation and an inequality? So stop and think about that for just a second. We use equations all the time. We should know that word really well. Inequality you should be familiar with. Here's the big difference. An equation has an equal sign, and inequality has an inequality. It's that simple. So when we say equal, we literally, there's only one symbol that we can be using there. When we're talking about an inequality, we can use a less than or equal to, a greater than or equal to. Any of those are inequalities. And of course, that little line underneath here, these two are called strict inequalities, but when they've got the little line there, they're maybe inclusive inequalities. That little bar is left over from the equal sign, so that means that that number that we get, it could actually be part of the answer. And hopefully that rings a bell. We're going to run through and go through some basics and then also remind you how to solve inequalities because they are very important, good skill to have. So the inequalities that I've got written here, they should make sense whether we read these forward or backward. It really doesn't make any difference. So take a look here. I've got 3 is less than 5. Now notice what happened here. I literally did a big, huge pancake flip. I flipped everything over, including the inequality. So notice the small point was toward the 3, big mouth was toward the 5. Same thing here. So this is 3 less than 5. This is 5 is greater than 3. Now watch what happens when I read these backwards. This is 3, it's on the less than side, so 3 is less than 5, and this is 5 is greater than 3. Both of them true regardless of which direction you read them. And then this one right here, x is greater than or equal to 2, or 2 is less than or equal to x. I'm going to read this backwards, and you'll notice that I'm going to say the same thing that I did before. X is greater than or equal to 2, 2 is less than or equal to x. So each one of these inequalities, each pair here, represents the same thing regardless of whether you read it forward or backwards. And you should be able to read and understand the inequality from each direction. That's really important. Okay. Now, it's usually best, regardless of which way it's written, it's usually best to read the inequality from the variable. Now, we talked earlier about how some people like always having the variable written on the left side or the right side. We should be good at leaving it on either side, and it's a big deal when we work with inequalities that we're able to read that from either direction. So, unlike equations, when we get one single answer, we don't get a single answer when we're solving inequalities. We get a range of answers. We get a whole bunch of answers. So the big question here, and I'm hoping a lot of you remember how to do this, the big question is, how do we solve inequalities? Well, we solve inequalities exactly like we solve equations. We do exactly the same thing. So we solve them just like we solve equations, except when we do one of two things. Except when we multiply, so let's write down multiply, or something else by a negative. Multiply or divide by a negative. And I'm hoping you remember what happens if we multiply or divide by a negative, because when you multiply or divide by a negative, you're introducing the idea of opposite. So what we have to do is we have to switch the direction of the inequality. We have to flip it from a less than to a greater than, or a greater than or equal to a less than or equal to, or something like that. So I've got a couple problems here. These are just reminder problems. So we've only got one page of notes here, I believe. Yep, looks like we've only got one page and a couple of thought questions toward the bottom. So when we're doing example 1, you'll notice that there's number lines where we can graph each one of these solutions. I only want you to graph them if the solution is a vowel. So if you take a look here, the first one has an A in it. We're going to have to graph that one when we're done with it. So here's how we're going to solve this. Just like we solve an equation, so we're going to add 10 to both sides. And every time you take a step, I want you to think, am I multiplying or dividing by a negative? If you are, you're going to switch the direction. If you're not, you don't switch the direction. We're adding, so that doesn't change the direction of the inequality. So we get A is less than or equal to, and in this case we get a -6. We're going to circle that. That's the answer as far as an inequality goes. Now we want to graph that. We want a picture of what this looks like so we can kind of see this range of all these answers that we've got. Okay, so the most important number on the number line here is -6. So I'm going to put a -6 right here toward this end, toward the negative end. I'm going to put a circle on it, and then I'm going to mark 0 on there. I think it's always a good idea to put 0 on there so we've got some sense of scale. So on our scale here, from here to here would be about 6 units if we have to write anything else on there. Now, the fact that it's equal to, it's got this little equal to bar, we're going to close in this endpoint. Okay, and it's usually best to read the inequality from the variable. So the answers, I like saying answers rather than variable here. So instead of saying a is less than or equal to -6, I'm going to say the answers are less than or equal to -6. They're on the small side. They're on the small point, so they're smaller than -6. So we're going to go this direction here. So I'm going to put an arrow on the end of that, and we're going to call it good. Now, this is one type of way that we can indicate the answer. We can circle that in and fill it in because that doesn't include -6, and then we can just draw an arrow, or we can do some shading. I'm going to do a variety of both so that you can see both different types. I kind of like shading better, and I'll show you that on the next one because we have to graph that one. That's a vowel. So there's the inequality, there's the graph. Both of those are parts of the solution. This is inequality form, and that's a graph form. So if you don't have both of those, you're not going to get all the points on an assignment or on the test. All right, let's take a look at this one. First thing we're going to do here, we're going to isolate that variable term. So we're going to subtract 5. So we end up with -6. So, whoops, let me just write it on both sides. We're subtracting, that doesn't change the direction of the inequality. So we've got an e right here. Now we're going to divide by -4. So we divide both sides by -4. Now when you divide by a negative, you have to switch the direction of the inequality. So I'm going to go ahead and switch that. I get an e right here. And then on this side, negative divided by a negative is positive. We can definitely simplify that. And 6/4, think of that as a fraction. 2 goes into both of these, so this would be 3/2. So here's our answer right here. This is the inequality that represents the answer. Now, we're going to graph this, so here's what we're going to do. To make sure everybody knows we know what we're doing, let's stop and think about this. Fractions are kind of a pain to graph, so 3/2 is 1 1/2. So here's what we'll do. I'm going to put 0 on here, and I'm going to put 1, and I'm going to put 2 on here. So everybody knows we know exactly where this 3/2 is. I'm going to circle this, so I'm going to circle it just like that. I'm going to label that as 3/2 because it can equal that. We're going to fill it in, and then we're going to read this from the variable. The variable is right here, so this says E is, or the answers are, they're on the small side, so they are smaller than, less than, or equal to 3/2. So we're going to shade this direction. And this is the type of shading that I really prefer more. A line on the top and bottom, and then just a little bit of diagonal shading in here. I think this definitely is easier over here, but I think this gets the point across a little bit better. So anything that's shaded is part of the answer, including the end point right here. So let's take a look at this. We're going to go ahead and solve here. We're going to subtract 35. Remember, subtracting does not change the inequality, no matter how big or small the number is. We get a -15 on this side. Again, we're not changing the direction. And we've got a 5u. We're going to divide by -5. We're dividing by a negative, so we're going to change the direction. And we've got a u on this side, and we've got a 3 on this side. So we're going to go ahead and circle that. Now, one reason why when we were solving equations, I didn't make a big deal about which side the variable ended up on. If you start flipping sides and saying, gosh, you know what, I really like to have the u on the other side, and you start flipping things around, if you don't flip everything around, including the inequality, it just causes problems. So you're much better off just leaving the variable on the side that it ends up on. Okay, so let's go ahead and graph this one. So we've got 0 here. 3 is the most important number on this number line. It is not included, so I'm going to leave that open. And then the answers are greater than the 3. The answers are on the big side of 3. So the answers are over here. So we're going to shade this direction right here. So a little bit of diagonal shading. And you can see the difference between these guys right here. Again, I like this type of shading better than just drawing a line. It is kind of up to you, but you want to make sure that you're perfectly clear when you're doing these. Okay, let's keep going here. Got a great example on this one here. Just like an equation, we always want to simplify before we solve. So I'm going to distribute through on both sides. So we get a -2x. This is a +6. Now, the big question here is, gosh, I multiplied by a negative here and I multiplied by a negative here. Do we need to switch the direction of the inequality? So think about that for a second. We multiplied by a negative on both sides. Do we need to switch the direction of the inequality? The answer to that is we do not. Because we were not taking a step in solving this. All we're doing is simplifying. Simplifying is never going to change the direction of the inequality. So on this side, we get -5x, and we get a +10. And then, again, there's an advantage to using those rules that we talked about when we were solving equations. If you've got a variable on both sides, you want to move the smallest one. And the smallest one is the most negative, so that's going to be this one right here. We're going to add 5x to both sides. Again, adding doesn't change the direction of the inequality. We're going to get rid of the 6, so we're going to subtract 6. Subtracting doesn't change the direction of the inequality. And notice what we have here. Negative 2x plus 5 is 3x. So we have a positive coefficient. We're not going to need to divide by a negative, and that's going to save us a little bit of a headache here. So we get a 4 on this side. We're going to go ahead and divide by 3. We're not dividing by a negative. So the answer on this one is x is less than or equal to 4/3. So I'm going to go ahead and circle that. There's our answer. We're going to put 0 on here. I'm going to put a 1 and a 2. 4/3 is, let's see, 3 goes in there once with 1 left over, so that's 3 1/3. So I'm going to go ahead and, 1 1/3. So I'm going to circle that one. Label that 4/3. Do we fill it in? Yes, we do fill it in. And we're going to shade, the answers are less than this number right here. So we're going to shade this direction right there, and I'll do that other type of shading. The rest of the time I'm going to do it the other way. Now, you'll notice that, gosh, this one wasn't a vowel, so I didn't need to do that. So all I'm going to do on this one is just solve this one. You'll notice that we've got fractions on both sides, and this is kind of a hassle. So here's what we're going to do. We're going to get rid of those denominators. So we're going to clear those fractions. So we're going to do something kind of clever. Now, you could do cross multiplying and stuff like that. You do have to be really careful with an inequality, though. So here's what we're going to do. We want to cancel off a -5 and a 4. So what's the smallest number we could multiply by that would cancel off a -5 and a 4? That would be a -20. So we're going to multiply both sides by -20. Now, when we multiply by a negative, we're definitely going to change the direction of the inequality. Let's see. The negative is going to cancel, and the 5 is going to cancel. That's going to be a 4. So we're going to have 4 times 2, so that's going to be an 8 times x plus 1. Pretty crazy here. This is going to cancel. That's going to make a 5, and we've got a -5 times that, so that's going to be a -15x. All right, let's see how things work out here. Distribute 8x plus 8. Distributing is not going to change the direction of the inequality. Now on this one is kind of a unique situation. On this one, there's only one constant, so I normally would move the -15 over here by adding 15x. Let's just move this guy over here. So we're going to move the 8x. So this is going to give us an 8. Subtracting doesn't change the direction of the inequality. That's going to be a -23x. We're going to divide by -23. So here's what we get. We get -8/23. We divided by a negative, so we need to switch the direction of the inequality. And we're going to have an x over here. So that right there is the answer. And again, it's an x, not a vowel, so we're not going to graph that. So we'll be good on that one. And then we're going to take a look at this one right here. So let's go ahead and distribute. 2u minus 4. Again, we distributed negative through. We're not multiplying both sides by a negative, so we don't change the direction of the inequality. A negative times a negative is a positive, and the 2's will cancel. Half of 2 is 1, so that's kind of nice that we don't have a fraction to deal with. I'm going to move this guy over here by adding 2u. We're going to add 4 to both sides. Okay, so those are gone. So 4u less than or equal to, this is a 5. We haven't done any multiplying or dividing by a negative yet. And we still don't, so we end up with u is less than or equal to 5/4. Now, I realize it's a hassle to deal with these improper fractions and stuff like that, but let's put a 0 here. 5 is a little bigger than 4, so this is going to be a little bit bigger than 1. So about right there. And do we fill it in? Yes, we do, because it can actually equal that. And the answers, the u's are less than or equal to 5/4, so we're going to shade this direction right here. So again, a couple little arrows, and we're all set to go. And then we're going to slide down here, and a couple of quick reminders. So just because there's a negative in the problem does not automatically mean that you're going to switch the direction of the inequality. It's only when you multiply or divide both sides by a negative. It's the step that you're taking that's going to change this. So when we were simplifying right here on example D, the negative 2 and the -5, they were already in there, so we didn't need to switch the direction of the inequality. It's when what we do, like on this one where we multiplied both sides by a -20, that's what can switch the direction of the inequality. And the other thing is, the solution to an inequality is all the numbers that make the inequality true. So let's take a look at this. What are some numbers that would make f above true? So f is right here. So any number that's shaded would make that inequality true. So you could use 0, That's shaded. You could use 1, that's shaded. That number right there, I forgot to label it, 5/4. That would work because that's shaded. We filled in that endpoint. You could do, gosh, any negative number you want. You could go as far as you want this direction. So we could do -100 or something like that. Is there a biggest number that makes that inequality true? Well, so the further we go on the number line to the right, the bigger the numbers are. So the biggest number that would work there is 5/4, that very endpoint. Now that would not be the case if it were an open endpoint. If it were an open endpoint, technically there wouldn't be a biggest because you could always just get a tiny bit closer to whatever that endpoint was. And then as far as the smallest, is there a smallest number going out on that end? Well, the number out on that end is really more of an idea, like -infinity. So the answer to that is no, there's not a smallest one. So with all that done, what I'd like you to do is give yourself a little assessment on how you feel like you are right now with solving and graphing inequalities. And then we're going to do problem 1 from the practice assignment. So here we go with the practice assignment, and we're going to look at number 1. Now, most of the problems on the assignment are very similar to what the notes were like as we were going through and doing those examples, but there are a couple that look a little bit different where they give you the graph and they want you to write down the inequality. So let me show you the easiest way to do that. So the answers are anything that are shaded, and we're going to represent that using an X. So I'm going to put an X right here. And then the smallest number that it could be would be 1. So I'm going to put a 1 right here. And then we're going to say those answers need to be bigger than the 1. Well, how do we make those bigger than the 1? Well, we have the small point toward the 1 and we have the big one toward the X. So we're going to write it like this. Now, because that's filled in, because it can actually equal that, we're going to put a little equal to sign underneath that one, and that right there is the answer. So you can do the same thing on each one of these and then you'll be all set to go. All right, good luck with the assignment.